2 over 3x is equal to 9 over 2. How exactly do we solve this equation? Step number 1, you got to tell yourself, look, I got to get rid of the 2 and the 3. And so one of the ways that you can do it is you can multiply by 3 over 2 on the left side and on the right side like this. And so when you do that on the left side, the 3's will cross off and the 2's will cross off. That right there, by the way, is called the multiplicative inverse. All right, know that name. And so you end up with x is equal to 9 times 3 is 27, and 2 times 2 is 4. And you may leave the answer that way, as I may have discussed with you in a previous lecture. You don't necessarily need to turn things into mixed numbers anymore. All right, let's take a look at number 22. Number 22 says that you've got 3 minus 2x is equal to 2 minus x. So it'll be a quick one, all right? And so we're going to go ahead and we're going to add x on both sides, or in other words, we'll bring the x over and then we'll bring the 3 over to the other side. So it'll become x minus 2x, which gives you a negative x. And if you're wondering why didn't you move the other one, that probably would have been a better idea, but oh well, now that we've done it. And then on this side, 2 minus 3 is a negative 1. All right, so you've got negative x equals negative 1, and therefore x is equal to positive 1, because if you divide or multiply on both sides by a negative, you'll get a positive. All right. Number 24, still, it's not entirely hard. Number 24, basically it's practicing to see if you know how to run with the distributive property. All right, so 3 times 2 minus x is equal to 2x minus 1. Step number 1, basically multiply the 3 into both of those. So you end up with 3 times 2, which is 6, and 3 times x, which is 3x. And on this side, you have 2x minus 1. Now you go ahead and you bring the negative 3x over to the right side and it becomes a positive, and then the negative 1 to the left side and it becomes a positive. So you end up with 6 plus 1, which is 7 on the left side, and you end up with 2x plus 3x on the right side, which is 5x. Then you go ahead and you divide by 5 on both sides, and then we always write down the answer with the x on the left, right? So it's just a habit of ours. It's a standard way of addressing things in mathematics. So there you go, x is equal to 7 over 5. All right, now let's continue on to number 26. Number 26, it says 5 minus 2x minus 1 equals 10. And in number 26, one thing you want to keep track of that's often forgotten by students who are just getting used to equations. Again, I know that you'll learn how to do all these, but the thing is, it's easy to forget all this stuff. Remember that whenever you have a subtraction sign before a problem, or before a parenthesis, that's going to cause the signs to switch. So that'll become 5 minus 2x plus 1 is equal to 10. It's not 5 times 2x and 5 times negative 1. I've seen students do that too, right? So this becomes negative 2x plus 6 equals 10, and therefore negative 2x is equal to 4, and therefore x is equal to negative 2. So notice how I'm not showing how I divide on both sides by negative 2 and stuff. The equations you're going to see are really, they're quite a handful, so you got to learn to move really fast through them. Number 28, it says 1 minus a half x is equal to 5. All right, so now what we'll do is we'll move the 1 over and it'll become a minus 1. So you'll have negative half x is equal to 5 minus 1, which is 4. And then if you consult what I did for you in number 20, right, how I started with number 20, that's what we're going to do here, is we're going to multiply this negative half by its multiplicative inverse. And its multiplicative inverse is negative 2 over 1, or simply a negative 2. And what that does is the following. It causes the 2's to cancel, the negatives to become positives, and what you're left over with is simply an x on the left side. And on the right side, you end up with a negative 8. All right, so we're moving right along, and I know that none of these problems are probably that difficult for you, so I'm just kind of going over them really quickly. All right, what about if we had some decimals in the system? So 0.92 is equal to 1 plus t. All right, here's a thought. Why not bring the 0.9t over, and that'll become a subtraction. and then bring the 1 over here. That'll become a negative. So it'll become negative 1 is equal to t minus 0.9t. All right. And this surprisingly has caught students off guard. They're like, wait, how do you do this? It's really just saying what's 1 minus 0.9? What's 1 take away 0.9? If you had $1 and you took away 90 cents, right? So what is that going to give you? So you end up with 0.1t. And now I'll go ahead and I'll detail this step for you. So now to solve for t, you would divide on both sides by 0.1. All right? So you end up with negative 1 divided by 0.1, which is negative 10, is equal to t. And again, a better habit is to write the variable on the left side and the number that's the answer on the right side. All right, let's continue to move forward. Now we're going to try number 32. Number 32, we're going to have to slow down a little bit and make sure everybody's with us and knows how to do this one. Number 32 says you got 4 over y minus 5 is equal to 5 over 2y. Now what do you do in this situation? So basically the first step is to make the common denominator through the entire problem, okay? And this step, this process, and we'll do this in a little bit again, this is called multiplying by the LCD, this method of solving this sort of equation. And the name of this equation is actually a rational equation. One of the best ways to solve a rational equation is to multiply by the LCD. Okay, so now the question is, what is the LCD? So let's see here. We've got a y, we've got a 1, and we've got a 2y. So you should be experts with the LCD and telling the LCD. So the LCD is 2y. Okay, now this is the part that's a little different than the previous lesson. All right, so listen carefully. You're not going to be trying to add and subtract fractions here necessarily. Your job is to multiply. That's why the method is called multiplying by the LCD. It's a lot easier, but students don't realize that sometimes. So here's what I mean to say. You're going to take 4 over y, and you're going to multiply that by 2y, like that. Okay? Then you're going to take the next fraction, which is 5 over 1. And I'm purposefully emphasizing that by making it 5 over 1. Otherwise, everybody knows that that's really a 5. And so I'm going to multiply that by 2y. And finally, on the right side, I've got 5 over 2y. I'm going to multiply that one as well by 2y. Okay? Now here's all the things that happen. In the first fraction, notice how the y's will cross each other out. So the y's are gone. But you still got a 4 and a 2 left, so you multiply those two and you end up with 8. Then in the second fraction, you have a 5 times a 2y, which is actually a minus 10y. And finally, in the rightmost fraction, this is the neatest one. Notice how 2y and 2y will cross off entirely, so you're left over with a 5. So now you will find the merit of actually learning this method. Essentially what this method does is it causes the fractions to disappear. All right, it's a really cool method. It's called multiplying by the LCD. So learn this method. It's going to get you out of a lot of fixes later on in upper level mathematics in high school. So now we'll move the negative 10y over here, and we'll move the 5 over here. That'll become a positive. That'll become a subtraction sign. So 8 minus 5 is 3, and negative 10y moved over is 10y. Now divide on both sides by 10, and your final answer is going to be y is equal to 3 over 10, like that. Okay? All right, let's continue moving. Now we're going to try number 34. Number 34 says x plus 2 times x minus 3. Okay, so let me write it over here. X plus 2 times x minus 3, and that is equal to x minus 3 whole squared. All right, so you are coming shortly after a lesson where we had these formulas that we established. You're going to find that I'm going to use them very regularly. So if you need to go back to lesson number, the one about factorization and polynomials, please do so. But basically, a minus b whole squared looks like that right there. Okay, so when you see something like x minus 3 whole squared, you're going to find quite often I'm just going to go ahead and make it x squared minus 2 times the first term times the second term, so that's minus 6x, plus the second term squared, so that's 9, like that. You see how quickly I did this, right? And that's how quick you're going to become as well. On the left side, that's the FOIL method. There's no tricks there. So you go ahead and you use the FOIL method. You're going to have x times x is x squared. X times negative 3 is negative 3x. 2 times x is positive 2x. You end up with minus x. And finally, 2 times negative 3 is negative 6. So altogether, the x squareds will cross off with one another like that. All right. If you don't understand what I just did there, a lot of students do struggle with that initial idea. So think about it. If this x squared came over to the right, it would take a negative, and it would cross off with the x squared that's already there. If, on the other hand, this x squared came to the left, it would take a negative, and it would cross off with the x squared that's already there. So why go through all of that headache? Just say that the x squareds, both being on either side of the equation, will actually cross one another out. Okay? Now what we're left over with is a negative x and a negative 6x. So what I'm going to do is I'm going to move the negative 6x over, and that will become a positive. I'll take the negative 6 over, and that will become a positive. So basically, you've got 6x minus x on the left side, and you've got 9 plus 6 on the right side. So 6x minus x makes a 5x, and 9 plus 6 makes a 15, and therefore x is equal to 3. Just a quick comment, something that students have asked in the past is they've said, when you wrote it like this, could you have written negative x plus 6x? Is that the same thing as writing 6x minus x? Yes, absolutely. They would both give you the same exact answer, which is 5x. So that's perfectly fine, just so you know that that actually works for you. All right, number 36, it says w times 4 minus w squared, and that is equal to 8 minus w cubed. Okay, so w times 4 minus w squared is equal to, whoops, I forgot what the question was, 8 minus w cubed. All right, so there you go. I got that all written out. Step number 1, you see a parenthesis and something before it. Your habit should be expand this, right? You can't really solve an equation until you haven't expanded everything first. So now you have the following on the left side, and on the right side you have 8 minus w cubed. Notice that the same logic as I was speaking to you about in number 34 applies over here as well. Notice in number 34 you had an x squared. Whoops, sorry. I apologize. You had an x squared and you had another x squared. Same thing on both sides, just cross it off. Make your life a lot easier, okay? So notice how you have a negative w cubed and another negative w cubed. So there's really no sense in doing much more with it. Just cross off the negative w cubes, okay? It doesn't matter which one you bring over. It's just going to work out for you either way. So now you have 4w is equal to 8, and now w is equal to 2. Give number 38 a shot. Number 38 says x cubed is equal to x squared. So now let me slow down a lot. First, let me give you the wrong method to do this. This has been like 90% of kids who come through have tried this in the past. Please don't try it. Do not divide. Okay, so don't divide by x squared. Never divide in a fraction, or sorry, in an equation by a variable. Don't ever do that. And what I mean to say is this. So let me show you what students have done in the past and incorrectly. All right, so they've divided on both sides by x squared and said, see, now this cancels out and gives you a 1. And on the left side, you end up with an x. So they say x is equal to 1. I'm just here to tell you that that is the wrong solution. That's not how it works, okay? So here is the proper way. So we're going to cross this off. I want to leave it there because I want you to learn that I'm not going to do it this way, right? So here is the proper way of doing it, all right? The proper way to try this problem is to first bring the x squared over to the left side. So it looks like x cubed minus x squared is equal to 0. That's step number 1. Then step number 2 is to use our old friend factorization, right? That's actually how you do this. So you factorize out the x squared, and you are left over with x minus 1 is equal to 0. Now, the way you solve this equation is basically you're saying that either the x squared is equal to 0 or the x minus 1 must be equal to 0. Because just think about it. If the thing in the blue highlighting was equal to 0, it doesn't matter what the thing on the green highlighting is, because 0 times anything still gives you 0. That's called the zero property in algebra. On the other hand, if the thing in the green turns out to be 0 altogether, then it doesn't matter what the thing in the blue is. It'll still multiply out to 0, because 0 times anything is still 0. So there's actually two answers to this question. And here is the proper way of saying it. You say either x squared is equal to 0, and therefore, if you solve that equation by taking a square root of both sides, you'll conclude that x must be equal to 0. So that's answer number 1. So oftentimes in upper level mathematics, they'll just go straight from x squared to saying that, and you'll be like, wait, what just happened there, right? Where did that 0 come from? So notice how in this left method that we had used, the wrong method, that was totally missed. We totally missed that conclusion, right? So that's why it's important to factorize. Now, what's the other answer? The other answer is to take the green highlighting and set that equal to 0 and solve that. And when you solve that, then you end up with one of the answers that you had originally gotten. But notice that you don't have both of the answers, and if you don't have both of the answers, then clearly that technique is flawed. It doesn't work. All right. Number 40 is really much in the same light, so I'm not really going to go over it. However, I will do number 42. It's a very important question. In number 42, it says that you've got negative 2 over x plus 4, and it's equal to negative 3 over x plus 1. So whenever you have a proportion, all right, this is called a proportion. Whenever you have a proportion, if you don't know what a proportion is, it's basically a fraction on one side and a fraction on the other side. The best way to solve proportions is to actually just cross multiply, all right? This is usually something students are very good with doing, is they do know how to cross multiply, all right? So you go ahead and you cross multiply in this situation where you take the x plus 4 and you multiply it to the negative 3, and you take the x plus 1 and you multiply it to the negative 2. This is not cross canceling, by the way. It's just called cross multiplication, all right? It's a technique of solving an equation. So you have negative 2 times x plus 1 is equal to negative 3 times x plus 4, like that, all right? Again, they go diagonally across. Then you have a distributive situation where you end up with negative 2x minus 2, and on the right side you end up with negative 3x minus 12. Now you can go ahead and bring the negative 3x to the left side and make it a positive. So 3x minus 2x will give you a single x. And you can take the negative 2 and bring it over to the right side, and negative 12 plus 2 will give you negative 10. And there you go. Your equation is already solved. There's not much there for you to do anymore. Okay? And the final problem that we're going to do from this set, then we go on to a slightly different set, is number 44. And in number 44, they ask you to multiply x minus 5 and 2x. So we'll do that in a moment. And then multiply x minus 5 and 4. All right? Now, please don't do this. Don't say, oh, look, there's an x minus 5 on both sides. Let me divide it on both sides. Remember what I said earlier. Anything with a variable, you're not allowed to divide it on both sides. And the logic behind that, if you're interested to know why is that, is because what if that x was a 0? Like, for instance, back in that problem where we had x cubed equals x squared, what if you divided by x squared on both sides, but x was equal to 0? Recall what we said, x can't equal 0. If x can't equal 0 in that situation, because of the fact that this is going to cause the denominator to become what? Undefined, right? So we can't have it to be undefined, therefore x can't equal 0. So dividing by x squared breaks that rule, right? You're dividing by a 0. And therefore, never divide by a variable on both sides, right? So what do you really do? Well, basically you expand this and say x times 2x is 2x squared, all right? Then negative 5 times 2x is negative 10x. So we got the left side all opened up. Now the right side is x times 4 is 4x, and negative 5 times 4 is negative 20, right? Now what we're going to do is we're going to move everything over to one side. So we'll move the 4x and we'll move the negative 20 over to the side. So you'll have negative 10x, subtract 4x is going to give you minus 14x. All right, and then the minus 20, when you bring that guy over, it'll become a plus 20. All right, so this clearly looks like a quadratic. So now we start switching gears and we start talking about solving quadratics, right? But before we get into that, realize that this can be very simple. Just divide out by 2 on all sides, right? Divide by 2, because notice how the 2, 14, and the 20 are all divisible by 2, all right? So when you do that, you have a slightly simpler, I guess, problem to solve. You have x squared minus 7x plus 10 is equal to 0. Now, to solve this quadratic, I would really refrain from using the quadratic, because remember, the quadratic formula is like the longest way of doing things, and you're going to have way too many questions to be doing the quadratic formula and everything. First, try to factorize, right? The number 10, does it have two factors that multiply to 10 and add up to negative 7? Those two factors are negative 2 and negative 5, right? So you end up with x minus 2, x minus 5 is equal to 0. Now, remember what I said to you earlier and apply that again. So what we're saying is in these two factors, right, x minus 2 is a factor and x minus 5 is a factor. In these two factors, basically what you got to realize is, listen, either x minus 2 is equal to 0, and that'll turn the equation into 0, so you end up with x equals 2 as a possible answer. Or x minus 5 must be equal to 0, and then, in that situation, x is equal to positive 5. So both of those are our answers. All right? And so that completes it for the first set. Now we're going to move on to a more challenging set. It's quite possible that nothing in this set was new to you. All right, in the second set, we're going to be working with some much more difficult problems. So let's start with number 46. Number 46 gives you a fraction in the first term. It says 1 over 2x plus 3, all right? Then it gives you another fraction. It says 1 over x minus 1. And you will see in just a moment why we're leaving all that space there, all right? And then on that last fraction after the equal sign, it says 1 divided by 2x plus 3 times x minus 1. So it looks like that right there. Okay, now recall what I had said to you earlier, that when you have a rational equation, this is a rational equation right here because it's got variables in the denominator. So whenever that happens, one of the best techniques to use is to use multiplying by the LCD. In number 32, we detailed this. So basically, this is just like number 32. It's just having a lot more going on. All right, so I just wanted to mention that to you first off. So we're going to use the technique of multiplying by the LCD. Now, what is the LCD here? The LCD would be 2x plus 3, all right, that's the first denominator. X minus 1, that's the second denominator. But notice that that third denominator happens to have both of those pieces, so it doesn't need to be multiplied by anything in case you're talking about LCDs, right? So that's our least common denominator. But now be careful. This is not adding and subtracting fractions. This is called a technique of multiplying by the LCD. So we're going to multiply every single term by 2x plus 3, x minus 1. Now notice how I multiplied each one of these fractions by the same exact common denominator. Now what is the benefit of doing that? Notice how the 2x plus 3's will cross one another out. So you're left over with x minus 1 for that first term. For that first fraction, sorry. Then for the next one, x minus 1's cancel out, so you're left over with 2x plus 3. So we're going pretty good right now. And finally, in that last fraction, this is the one that's the neatest, is normally everything will cross off. And so basically, what are you left over with? You just have a 1 there. So what initially looked like a really crazy looking problem, it's so much easier now. X plus 2x is 3x, and 3 minus 1 is 2, and that's equal to 1. So 3x is equal to 1 minus 2, which is negative 1, and x is equal to negative 1/3, like that. All right. Next one, number 48. Now in number 48, we switch gears and we talk about solving absolute value equations. So you want to first write down what type of equation this is. This is called the absolute value equation. All right, so we're just coming up from rational equations. We've done linear equations. We've done quadratic equations. So this is an absolute value equation. All right, and for that, what we'll do, we'll take number 50 instead. All right, let's take number 50. Number 50 says that you've got the absolute value of 3x minus 1 is equal to 2. All right. Now, on a number line, absolute value, it basically means that wherever this number may be, right, wherever this number may be, let's call that number, let's just call it like C, all right? And it's a little bit abstract, but you have to know this definition though, okay? You can go 2 units towards the right, right? You can go 2 units towards the right, or you can go 2 units towards the left, and you will get to the distance that we're talking about. So absolute value, that's really what it stands for. It's the exact distance from the center. And just to put some more teeth to this, pretend that I asked you, how far do you live? And you tell me that I live 5 miles north, right? And then I ask another person, how far do you live? And they say 5 miles south. So basically, absolute value, what it really does is it says we don't care about the north and the south. What we really care is how far you live. You get it? So you really live 5 miles. So the absolute value, that's its relevant meaning to our lesson. So now how do you actually solve this? Basically what you're saying is, look, that means either 3x minus 1 is going to equal out to positive 2, or 3x minus 1 is going to equal out to negative 2, like that, all right? And so what I'm trying to imply here is the following, all right? What I'm trying to imply here is the following. You will solve each one of these problems, okay? So the first problem becomes 3x is equal to 3, x is equal to 1. The second problem becomes 3x is equal to positive 1, because that negative 1 moves over and it becomes a positive 1, and then negative 2 plus 1 is a negative 1. And so x is equal to, bismillah, 1/3, right, with the negative on it. So negative 1/3, all right? And so what are we really saying with that? What we're trying to imply is if you were to plug the number 1 into this equation, all right, let's just check our work. This is so important, and it confuses students because they don't really pay careful attention to this, I've seen. So pay careful attention to this. What does that equal, right? What's 3 times 1? That's 3. Minus 1, that's 2. What's the absolute value of 2? It's 2. So this solution actually checks out. Now, the one on the right, that's often missed by students. They don't really think about it that way, right? So let's plug that negative 1/3 into this problem. So you have 3 times negative 1/3, and you subtract 1, right? What's going to happen? The 3 and the 3 are going to cross off. So you'll be left over with the absolute value of negative 1 minus 1, which is equal to the absolute value of negative 2. And what's the absolute value of negative 2? It's actually 2. And so what I'm trying to say here is that's why we broke this up into 2 spots. What happens is a lot of students, they only remember that we were taught to break things into 2 parts, and that's all they do. But on the ACT, they ask you a question that's slightly different, and then you're looking at it going like, what does that even stand for, right? So what it really stands for is the distance from where you are is 2 units, whether you go towards the left or towards the right. So this is how we solve it. These are the steps. You basically first take the 3x minus 1 and equal it to 2, but then you say, I'm going to take the 3x minus 1 and equal it to negative 2, because the absolute value of negative 2 is still positive 2. All right? Try to absorb that and learn it. You will eventually wrap your mind around that kind of abstract thinking, but it's very important though. Okay, now we're going to try, we're going to continue with absolute values because that can get a little bit tricky for students. So let's take a look at number 52. Number 52 says that you've got the absolute value of 1 minus 2z is equal to 3. Once again, same exact idea. What we're saying is either 1 minus 2z is actually equal to 3, or 1 minus 2z could have been equal to negative 3, but the absolute value of negative 3 is still positive 3, right? So in this first situation, you have negative 2z is equal to 3 minus 1, which is 2, and therefore z is equal to negative 1. So that is one solution. And the other one is negative 2z is equal to negative 3 minus 1, which is negative 4, and then divide by negative 2 on both sides, so z is equal to negative 2. Sorry, positive 2, right? And I just want to just kind of show you something here, just so you realize what we just did here. All right, let me make a number line. All right, let me make a number line, a nice number line. So here's a number line for you. And I'm going to mark down negative 1 on one side. And I'm going to mark down the number 2 on the other side. Okay? And I just want you to think about this. It's just that meaning behind it is so worthwhile. What's the number that's in the middle of the two? I want you to think about that. Let's call that number C. But what is that number exactly, right? Use the midpoint. So you got a negative 1 and you got a 2. Negative 1 plus 2 is 1. And if you divide 1 by 2, right, to get the midpoint, you end up with 0.5. So C is equal to 0.5. Now here's the cool thing. If you were to go from 0.5 towards the right, let me ask you, how far did you go, right? That distance that you went must have been 1.5 units. All right? That's 1.5 units. What if you went towards the left from the center? How far did you go? You once again must have gone 1.5 units. And so what I'm trying to help you understand in this problem is basically when we say 1 minus 2z, its absolute value is equal to 3, that doesn't necessarily mean you go to the number line and mark those as 3's, right? That's not what that stands for. And so you want to kind of be able to understand that as well. All right, let's try number 54. Number 54 looks quite odd. It says the absolute value of negative x is equal to 1. And I would really recommend you just kind of stick to the story here. And the story is what? Case number 1, you say either negative x is equal to positive 1, or somehow negative x is equal to negative 1. And you know, I say somehow because what we'll do is we'll check our answers. We'll make sure it's making sense to you, all right? So in that first case, x is equal to negative 1, and we're done with that answer. We'll check, does that work or not? And in the second case, x is equal to positive 1, and that's our answer. Now let's do a little check, all right? Let's go back to the original question, all right? And where it says absolute value of negative x, let's plug in absolute value of negative 1, because the x value is negative 1, and that actually gives you the absolute value of 1. And what's the absolute value of 1? It's 1. So this one is good to go. All right, let's try the other one. Let's try the other one. When you plug in a 1 into that expression, you end up with a negative sign and then a 1, right? And what is the absolute value of negative 1? It's still equal to 1. So in fact, these are both correct answers in this situation. All right, number 56, that's a funny looking one. Again, they're just kind of giving you every flavor just so that you don't get tricked later on when you see these types of things. So it says, what's the absolute value of 3 times x equal to 9? Now, you see, this is why it's so important to read the question before you make any decisions. Notice how the absolute value sign is not, all right, the absolute value is not on an x, right? It's not including the x. So guess what? There is no ambiguity here. Like there isn't two answers, because what's the absolute value of 3? It's 3, right? So you end up with 3x is equal to 9. And what is x equal to? X is equal to 3. All right, so that question has gotten students in the past. Here's another question that's gotten students. Actually, when I began my teaching career, it got me, and I was quite embarrassed. Because I wasn't thinking about it. I was just going about things. So number 58 says the absolute value of 2 minus x is equal to negative 1. And I want you to just stop right here. Okay, just stop right here and say that this is no solution. All right. Now, why exactly did I say that? It's because just think about it. How can you possibly take the absolute value of anything, right? Don't worry about the 2 minus x. Don't worry about that. If I tell you that I took an absolute value of something and I ended up with a negative number, what are you going to say to me? You're going to say, you're crazy. That's not possible, right? Because absolute values, one thing we remember is they always turn things positive, and this is clearly not a positive number, right? So that one, it's a tricky one, but it's just a bad question if you want to think of it that way. All right. Now let's do number 64. Number 64 requires a little bit more space. It says x to the power, x squared plus 3x minus 2. Here, let's just kind of put this over here. All right, so x squared plus 3x minus 2, all inside of an absolute value sign, right? So that's interesting. I don't think you've ever seen something like this before, right? So like that, and then it's equal to 2. So you want to stick to what you've been taught, all right? Now, first off, this is not a no solution. There's definitely a solution to this. And what you've been taught is, listen, there's going to be two situations. Either what's on the inside of this absolute value ends up being equal to a negative 2, and when it equals a negative 2, the absolute value is still 2. Or this equals a 2 and its absolute value is still 2. So having said that, basically what we're going to do is we're going to split this up into two cases. We're going to say x squared plus 3x minus 2 is either equal to 2 or x squared plus 3x minus 2 is equal to negative 2. So those are the two situations that we're looking at. In situation number 1, if you solve the equation by bringing the 2 over to the left side, you'll notice these are both quadratics, right? So x squared plus 3x minus 4 is equal to 0. So now let's solve that quadratic. And remember, don't just jump to the quadratic formula. You're going to run out of time in these assessments and stuff like that. So you end up with 1 and 4 with a negative on the 1. So you end up with x minus 1, x plus 4 is equal to 0. And therefore, there's two possible answers to this case. Either x equals positive 1. Remember the logic. X minus 1 is equal to 0, and therefore x is equal to 1. And the other possibility is x is equal to negative 4. And so those are your two possibilities there. And we're not done with the question yet. Now we got to go look at case number 2. Now in case number 2, let's go ahead and do the same exact process. We'll bring the negative 2 over. It becomes a positive 2. So you end up with x squared plus 3x is equal to 0. All right. Now to solve this, remember what I told you earlier, factorize, right? So the factorization of something like that was quite unique, right? It's a way of going about it. Now what do you do here? Many students get stuck. They're like, wait, how do you factorize this? Remember, whenever you're factorizing, the first thing you do is look for commons, and what was common was an x. Now in this situation, you have two answers yet again. Either this x right here is equal to 0, and therefore x is equal to 0, or this x plus 3 is equal to 0, and therefore negative 3. So now take a look at the number of answers that we've got. We've actually got 4 answers that work for us. There is 4 numbers. All right, there's 4 numbers, 1, negative 4, 0, and negative 3, all of which you can plug into this equation, and I won't check my answer because that'll really elongate the lesson, and you'll find that you have the correct answer. All right. Now let's move forward to number 66. So notice how I'm taking the time to go through all the evens with you, just so that you don't feel stuck, right, when you're doing your homework. It takes a while to do these, but now step number 1, don't divide by x on both sides. I detailed that for you. I don't want to scroll up again because already the lesson has gone long enough, but don't divide on by x on both sides. You want to just remember my words there, okay? And so what you really do is you first bring the negative 8x over to make it look like that. So you bring it over the equal sign. Then you factorize, all right? You factorize. And so now you're saying either x must be equal to 0 or x is equal to negative 8. Those are the two possible answers that actually exist over here. All right, number 70. We'll skip over number 70 for now. Actually, no, let's go ahead and do number 70. That's important. So number 70 says that you've got 3x squared plus 5x plus 2. So just think to yourself, how do you solve this? Step number 1, multiply the 2 and the 3, and you end up with 6. But now let's slow down a little bit, and this is why I'm doing the question. Remember in the factorization lesson, right? If the number out front is not equal to a 1, that a value is not equal to a 1, you cannot go through the easy technique of factorization. You need to go through the longer technique. So the longer technique goes as following. If you've got 3x squared plus 5x plus 2 is equal to 0, and you multiplied the 2 and the 3 and you got a 6, you're looking for two factors that are going to add up to 5 positive and multiply to 6 positive. So those must be 2 and 3. Now, here's the long method. 3x squared plus 2x plus 3x plus 2 equals 0. That's step number 1. Step number 2 is you're going to go ahead and group these. So in the first group, you have x in common, so you have 3x plus 2. Then you copy that addition sign, right? We did all of this in lesson number 8. Then what's in common between 3x and 2 is a 1, so you're left over with 3x plus 2. Remember, now you're solving an equation, right? Now we're going to factorize out the 3x plus 2, and what's left over is an x and a 1. So x plus 1 is equal to 0. Now, this is why it's so important to know a particular process instead of remembering tricks and whatnot, right? So notice how there's two factors, one in the blue and one in the green. The one in the green, it's really easy to tell what the answer to that is. The answer to that is -1, right? If x was -1, that would cause this thing in the green to become a 0, which multiplied to anything in the blue would still give you 0. But the thing in the blue, not everybody gets that, and usually they don't get it because they weren't learning the proper techniques of doing things. So here's the proper technique that I highlighted for you in the beginning of this lesson. First set 3x plus 2 equal to 0. Then go ahead and solve, and you'll end up with -2/3. So the first answer is actually -2/3. Just for sake of completeness, x plus 1 equals 0, and the other answer is x equals -1. So you know how some students say, oh, just switch the sign, just switch the sign. That's why they say switch the sign, but be careful that you switch that sign when the x is just holding on its own. When it's being multiplied to something that doesn't quite work for you. Okay? 74 says the following. It says 25x squared plus 16 is equal to 40x. All right. Now, it doesn't quite look like the quadratic, because remember, the quadratic needs to look like this. And then after that, you try to solve it through factorization or the quadratic formula. So to make it look like that, the first thing you have to realize is bring the 40x over. Okay, and initially a lot of students, they're like, oh man, I missed that. So you got to make it look like the quadratic, right? So 25x squared minus 40x. Look at where I'm putting the minus 40x, because I want to make it look like this format, right? I want to put the bx in the middle. And then plus 16 is equal to 0. Now, you want to think of two factors. When you multiply 16 and 25, I believe you have 400, right? So you can pause the video, and you can think to yourself, what are those two factors that multiply to 400 yet add up to -40, all right? And so those two factors are -20 and -20. Now, once again, as I said to you in that previous problem, you can't go through the easy method of factorization because that number is not equal to 1. If it was equal to 1, then it would have worked for you. So you got to go through the longer method. Now, what's the longer method? Let's go ahead and run through it once again. You go ahead and you write down 25x squared minus 20x minus 20x plus 16 is equal to 0. That's the first step. Then you go ahead and you factorize in groups. So you have 5x in common in the first group, and you're left over with 5x minus 4. And then you copy down that subtraction sign, and you have 4 common in the next group, because 4 goes into 20 and into 16. It is the greatest common factor. And so you're left over with 5x minus 4 in that group. You may check my work, by the way. Okay? So now you have 5x minus 4 that's in common in the first two terms, and what's left over is also 5x minus 4. do you realize that you just basically have the same thing repeated twice? So if you were to take that first one and say, I'm going to go ahead and solve it, you do realize you're just solving the same thing 2 times, right? So just go ahead and solve this once. 5x minus 4 equals 0. Therefore, 5x is equal to 4. Therefore, that value of x that will cause this to become a 0 is 4/5. All right, and that's number 74. So we're almost done with this lesson. Let's take a look at number 76. Number 76 says x plus 12 over x equals 7. Okay, so number 76 says x plus 12 over x is equal to 7. Now, initially, students get all kinds of ideas to solve this, and I don't want you to brush over this just because it's the end of the lesson. But look, you have to realize this is a rational equation. Why is it a rational equation? Because it's got an x in the denominator of one of the fractions. If any one of the fractions has a variable in the denominator, it automatically transforms into a rational equation. So what I'm trying to imply here is really you have an x over 1 and a 7 over 1. And what you want to do is you want to use the method that we detailed earlier. You want to multiply by the LCD. All right, so what's the LCD? The LCD is simply an x. So we're going to go to this equation and we're going to multiply every single constituent by x. So I'm going to multiply this by x, I'm going to multiply the second fraction by x, and I'm going to multiply the final fraction by x. Right? So 7 over 1. Well, what's going to happen? In that first fraction, it's going to become x squared. In the second fraction, the x's will cross off and you'll be left over with a plus 12. And in that last fraction, you'll have 7x. Now you have x squared minus 7x plus 12 is equal to 0. And therefore, negative 12 has two factors, and those, sorry, positive 12, I apologize, has two factors, and those are negative 3 and negative 4. Now this is the easy method of factorization because you don't have that first term being a number that's not equal to 1. So now you can go ahead and just jump the gun and say, well, then x must equal 3 and x must equal 4. Now it's acceptable to have made that conclusion without a whole lot of work. All right, let's go to the last question for today, and that is number 78. Number 78 is yet another equation that you have to solve using the method of multiplying by the LCD. So 5 over x plus 2 is equal to 4 plus 3 divided by x minus 2. All right, and let me do the following. Let me give some space between these, right? So let me give some space here. All right, again, how do I know this is a rational equation? It's because there's variables in the denominators of at least one fraction. So first, let's make everything look like a fraction. So there's your 3 fractions. I've just kind of spaced them apart for you. Now, the LCD in this situation is x plus 2 times x minus 2. All right, that takes care of one of each kind. Now we're going to multiply each one of these by x plus 2, x minus 2. So x plus 2, x minus 2, that's why I left that space for you. And then you're going to see what can you actually cross off, right? So in that first situation, you can cross off an x plus 2. In the second situation, you actually can't cross off anything. But in the third situation, you can cross off an x minus 2. And remember, the whole purpose of this is it saves you the dealing with fractions. So that first one becomes 5 times x minus 2. The second one becomes 4 times x plus 2, x minus 2. And the last one becomes 3 times x plus 2. Now, let's pause a little bit. Remember that this is of the format a plus b, a minus b. And whenever something is of that format, you can make the conclusion that it's equal to a squared minus b squared. So I'm going to use that logic and say, well, then x plus 2 times x minus 2 must equal x squared minus 4. But remember, it's still being multiplied to a 4 here, so I'm going to write the 4 here, okay? On this part of the equation, that just becomes 5x minus 10. And on this part of the equation, that just becomes 3x plus 6. All right? Now, we're not done with this yet, right? We still need to continue. So now you have 5x minus 10 is equal to 4x squared minus 16 plus 3x plus 6. And now when you try solving this by bringing the 5x over and the negative 10 over, you'll have 4x squared, right? When you bring the 5x over, that's going to become a minus 5x. So 3x minus that 5x is going to give you minus 2x. And on the right side, notice how you have a, let me just highlight this for you so you don't miss it. So you got a negative 16 and a plus 6. That gives you negative 10, right? And then when you bring this negative 10 over, what does that do? That becomes a positive 10. So in fact, that part right there is just going to cross everything off, right? That negative 10 is going to cross off with what you get from there. So really what you're looking at is an equation that looks like this right here. When everything from the left side left, when it exited, you ended up with a 0 remaining on the left side. Now this is a very awkward way to solve an equation. So what we generally do is we rewrite that equation with the equal sign and the 0 on the right side of it. Okay. Now ask yourself, what have we learned in this lesson to deal with this equation? Step number 1, factorize out the 2x. You're left over with 2x minus 1 is equal to 0. So now you have two situations. Either the 2x is equal to 0 or the 2x minus 1 is equal to 0. So let's go ahead and solve these individually. If the 2x is equal to 0, that means if you divide by 2 on both sides, x is equal to 0. On the other hand, if 2x minus 1 is equal to 0, then 2x must equal 1, and therefore x is equal to 1/2. And so that is the other answer that you get. All right? Thank you so much for listening, and good luck with doing the homework.